Excel gives up at about 1,000,000 rows. Pandas dies when your RAM runs out. Now look at this table, 20 billion rows, and my code treats it like a spreadsheet. Filter, group, sort, no sweat. Here's the twist. This table doesn't exist. No machine has it. No file contains it. It's the most useful lie in data engineering, and it's called a data frame. A data frame is a distributed table. To you, it's rows and columns with names and types. One clean table you can query. To Spark, it's something else entirely. The rows are sliced into the partitions you know from episode 1, scattered across the cluster. 20 billion rows. That might be 2,000 partitions, 10 million rows apiece. The table is the interface. The partitions are the reality. You work with the lie, Spark deals with the truth. Every data frame carries a schema. Each column has a name and a type. Endpoint is a string, status is an integer, latency is a number. The schema is a contract. Because Spark knows the types up front, it can pack data tighter, skip what you don't need, and catch nonsense, like averaging a column of URLs, before burning an hour of cluster time. Print it anytime with printSchema. Here's what trips up beginners. You can never change a data frame. No updating a cell, no deleting a row. Every transformation, filter, with column, drop, returns a new data frame and leaves the old one untouched. Why so strict? Remember episode 1.2. A data frame is really a recipe in a DAG. Recipes compose, edits don't. Immutability is what makes lazy evaluation and safe parallelism across 200 machines even possible. Where do data frames come from? Anywhere tabular data lives. JSON, CSV, Parquet files, database tables, existing views. One red call, and whatever the source looked like, you get the same thing back, the same table interface, the same operations. Learn the API once, apply it to everything. And what can you do with it? Everything a table promises. Pick columns with select. Keep rows with filter. Combine tables with join. Summarize with groupBy. Every one of these verbs is a transformation. And you know what that means from last episode. Lazy, stacking up in the DAG, waiting for an action. You chain them like Lego bricks, and the optimizer rewrites the whole tower before it runs. Module 2 is where you'll write these in your sleep. For now, just remember the shape. Table in, table out, every single time. But I already have data frames in pandas. Same word, different beast. A pandas data frame lives in one machine's RAM and executes instantly. A Spark data frame is distributed and lazy. Nothing runs until an action. The API feels familiar on purpose. The behavior is not. Keep the rule from episode 1. Megabytes, pandas, tens of gigabytes and beyond, Spark. Let's touch 1. Our web logs again. Read the folder, and Spark hands back a data frame. printSchema, there's the contract. Endpoint is a string, status is a long, latency is a long. But look at TS. Our timestamps came back as plain strings. Keep that in mind for a minute. Show 5. A clean table, straight from the raw files. Count, 40,000 rows in this demo. And this exact code wouldn't change with 40 billion. Same lie, any scale. Now the trap. Remember job 0 from last episode? The job that ran before our query even started? That was Spark reading your files just to guess the schema. Inference means an extra pass over the data. On 2 terabytes, you pay a full read before doing any work. And a wrong guess poisons everything downstream. You just watched it happen. RTS column is a timestamp, and Spark guessed plain string. The fix: declare your schema explicitly. We'll write one in module 2. Free exploration? Infer away. Production pipeline? Declare the contract. Quick recap. A data frame is a distributed table. Interface up top, partitions underneath. The schema is its contract. It's immutable. Transformations build new recipes, never edits. It reads from anything. And it is not pandas. Enough theory. You've earned your hands. Next episode, we build a real Spark environment on your machine, from 0 to your first query in 15 minutes. Bring a laptop. See you there.